Okay, hello everybody, this is Lincoln. Now what we're doing today is working through another tutorial file and session. And this time what we're looking at is the situation where you need to decide how many different types of units to make, where one or more units will actually be consumed then in the production of other units. Now the case I've used in this we're working through here is the case of jandals, where you can make a sort of a basic pair of jandals which could then be sold to somebody else, or they could be used to form a more premier or a better type of jandal which can then be sold to consumers, or these premier jandals can then be packaged into boxes of 5 and sold to a big department store. So in each case, the different types of jandals, products A, B and C, can sort of be consumed then to produce other types of jandals. Now obviously if we consume one product to make another product, we can't then sell it. So what we can see here is what we're going to start with. Now the hours of labour we read from the question. To make a jandal or product A is 1. To make product B is 2, and then product C is 1. Now, product A is going to require no units of product A. I think it's fairly obvious. Inputs used, product A in order to make one, we'll go down column A. Inputs of B to make A is 0, inputs of C to make A is 0. Now next column, inputs of A to make a unit of product B is 1, inputs of B to make B is 0, input of C to make a unit of B is 0. Now units of A to make C is 0, units of B to make C is 5 and is 0. Now the selling price per unit is 5, 20 and 105 respectively, and the total number of hours we have available for the workers down here is 80 labour hours each day. Now this section here, which has been shaded in blue, this is what solve is going to change, so we don't need to worry about that. And see there, that's what the comment says as well. Solver will change these values. Now, next thing I'm going to do is look at this table here. Table C, the production and sales plan. Now as I said, the units produced is going to be set by solver. That's ultimately the managerial decision, which is how many units we need to produce. Now the next row down, the units used in production. Okay, sorry, just got interrupted. Now the units used in production here, these cells. Now these are going to be the units, so say if we had produced 1 unit of A, and we use that unit of A in production, we could then produce 1 unit of B. And we know this because 1 unit of A is used to make 1 unit of B. So there's 1 unit of A as an input for 1 unit of B. Okay. Now, table D, this table here. What we're looking at here are the units of products to make other products. So what we need to do is actually figure out how many of each unit of product is used to make other products. So we need to know the amount of the inputs of these products here on the vertical that are used as input to make a product on the horizontal. So here 1 unit of A is used to make 1 unit of B. So that will be one input into this table. Now the other input will be the actual number of units produced from here. So we need to know how many units of B we're going to make. Okay, so if we consider making 1 unit of product B, it's going to require 1 unit of product A. So we'd have a situation like this. So now in table D, C22, this entry would be 1. So we've actually consumed 1 unit of product A to make 1 unit of product B. Now the total number of units of A consumed will be the sum there. Now, a value going in here will be equal to the actual units of A produced, and then we're going to hit F4 now. Now we don't want an absolute reference to this cell where it's $B, $16. We want to change it so it's an absolute reference to row 16, and you'll see why in a moment. And we want to multiply this figure now by B6, or the actual input of A to make A. Now in this case, fairly obviously, this is 0. Now if we pull this down, then we pull this across, it is now automatically reflecting. And what it's doing here, so if you look at this cell here, the number of units of B consumed to make product C, it is equal to this blue cell here, units of C produced multiplied by the number of units of B required to make 1 unit of C. Now, and as I said, now for table D we have the total here, which is the total number of units of A consumed in these 3 cells to make other products. Now that was easy to tally up there, but you see here, this number here, the actual units consumed or used in production, is what we want to have put into these cells here. Now there's a bit of a problem in that these cells here on the horizontal, while these cells here are on the vertical. Now we're going to use an array function called transpose. And what transpose will do is it will take what is on the horizontal and it will make it onto the vertical, like that. So if we transpose that, we will get that. Now, the way in which we do it is we highlight the cells where we want the entries in, we type in equals transpose, and then we enter the array that we want, close brackets. Now remember, we have to hit Control, Shift and Enter for a function for an array like this one. Now, what we need to do here, the remaining units sold is obviously equal to the units produced minus the units used in production later. Now what happens here, so in this case here, we can see that 1 unit of A was produced and 1 unit of A was used in production, so there are no units of A remaining to be sold. In this column here, 1 unit of B is produced, but no units of B are used in production, which means that there's 1 unit of B remaining that is sold for revenue. Now, what we're going to look at now is the constraints. First one I'd like to look at is the labour hour constraints, and the number of labour hours used. Will be equal to the sum product of the number of units produced multiplied by the hours of labour required for each product. Now what we can see here is that 1 unit of A is produced requiring 1 labour hour. We're going to add to that the fact that we produced 1 unit of B which required 2 labour hours, which means that we should have a total of 3 labour hours that we used. Now this constraint here means that the number of labour hours used must be less than or equal to the number of labour hours available, which we'd previously specified in the model. Now the units produced must be less than or equal to the actual units used, I think. So we'll just leave that blank for now. Now the units used total is going to be found by the units used in production, and add to that the remaining units sold for each one. So units used in production for A plus units remaining to be sold there like that, and so on for B and for C. Now the units produced is obviously just equal to the managerial decision which solver is going to give us. And I think for these, the constraint that we're going to use will be an equal sign. Be equals. So that however many units we produce, we must use them in one way or another. So we must either, in the case of B, we produced 1 unit, which means we either use it in production or we sell it. Now, revenue will be equal to the number of units sold by the price per unit, so we're going to equal to the sum product of units sold multiplied by the price per unit. Now I think we've got everything we need in the table, and what we're going to try and do now is run solver and try and get a good solution. So we'll load up solver. Now first things first, options, we're going to assume that it's non-negative. We're going to set tolerance equal to 0, so we've got an exact solution, and we'll assume a linear model. Now the target cell will be the revenue, because we want to maximize the revenue. We set equal to max. So we want to maximize the revenue. Now we're going to do this by changing the cells, and the cells which we want Excel to change are the cells which are going to be related to the managerial decision. Now in this problem they've been highlighted in blue for you. So Excel, or the manager, has to decide on how many units of each type of product to produce. Now there's going to be several constraints. I think pretty obviously the units produced should probably be an integer. We don't want to produce half a pair of jandals. That's no good to anyone. Now the hours used each day must be less than or equal to the actual number of hours available. The units produced should be equal to the number of units used. Oop, no, what I've done, sorry. Now, you might be able to get away with a greater than or equal to, so we don't use everything we produce. So the production must exceed the amount of units we use. So in other words, what we're trying to say is we can't use more units than we have actually made. Now the units produced and one more. What we're going to say up here is the units produced must be greater than or equal to the units in production. And if we don't do that, Excel will come up with some funny figures for us. Now we're just going to go OK now, and we run the solver, and Excel's come up with a solution of 530. Now that should be the maximum amount of revenue we can get, and you can see that Excel has decided to make 26 pairs of product B here for sale and 2 pairs of product A. By doing this, all the labour hours available have been used, and we can see that 26 units of product A have been consumed to make product B. So this all looks good. 26 times 20 plus 5 times 2 should equal 530, so that looks correct as well. And so Excel's given us a good answer here. So congratulations, you've just solved the problem. Well done.